Okay, so hear me out. So you know how Tony Stark has a space station filled with drones? Drones with these space capsules? So I was thinking, there might be a way to make more war uses with the space stations using space. So matter isn't made. It isn't made, but it's repurposed. Matter is not created, it is repurposed. So I'm thinking, what if what if someone made a cannon in space, uses like it's using accelerators to repurpose use matter in space, because that's the highest concentration of matter with rocks. So import. So this is import. Import. So this is importing rocks. Lots of rocks. So it's like rocks are going into it. And a bunch of rocks are going in. And I was thinking, what if we just... So rocks go in the top. It accelerates some into making light. So if it makes light, we just make beams of light coming down from sky. Oh, my hearing is really bad. But yeah, we can make beams of light. Just beams of light. So, like, I was thinking, if I made a beam of light like this, made out of matter, and that matter is then artillery, because we can... I was thinking, no, because hear me out. We can make suns. China is making suns. China is able to make suns. So why can't I make a beam of light from outer space, taking rocks, repurposing it through an accelerator, and melts it down into liquid, which then that liquid then re-enters the atmosphere of pressure, which then reignites it. So it's pretty much getting shot down. So it's just gonna be a rock melted down. So it's gonna be molten lava. Molten lava. Space rock. It's molten lava space rock. So if that space rock is then falling towards Earth, and then the re-entry, because there is 3 layers: the ozone layer, the ozone, and then something about something up top, above ozone layer. But when the rock re-enters space, because it's pretty heavy, it's not going to be affected by wind, because it's going to be heavy. Wind is going to have, since it's a block, wind is going to be going this and this, which then is going to make it drop faster because of weight. So if this is you or your opponent, it's just going to come down. Which, if we have multiple rocks coming down and we do multiple rocks, we could just make a big implant of rocks incoming, like little asteroids, like Thanos. Because Thanos is able, because if you remember, Thanos was able to bring a moon to he was able to bring asteroids from it. So he's like breaking apart planets to fire back at them, at the Avengers. Which it didn't, but that was only because there's a magnetic force in them. Magnetic force. But if we do that, because this would have to be spinning at high velocities. But then if a different country finds out about it, then they're just going to be firing at it and shoot something back towards it. So we should probably put safety precautions into it. We could do a magnetic pole that pulls it, because it's going to be metal. Metal is going to be fired at it. Or if it's energy blast, to stop it. To fire the hoverboard and viral components. Which we could do is make a system of movements. Like, all we could do is what's something that's able to travel around the road really fast? A thruster. But then we don't have the stabilization, so we should use the stabilization in the gyro. So basically the gyro has spinable force in the insides with something that is able to turn it either way. So the gyro is able to spin in that way, so that it just rotates it. But we could also then set up a second one facing this way. So we have a stabilization and a rotator to keep it from going that way. So we have beams of light, molten lava, re-entry, which means going to start turning them liquid about right here. But lava doesn't have magnetic force, and they're just going to get blown up. But if they get blown up, they're just going to spatter lava everywhere. But shouldn't it won't be that cool scene where there's just beams of light coming down from heaven? Like from One Piece, you know? So it's like this. Like from clouds, there's beams of light coming down, destroying islands. You know? But those are just beams of matter just getting shot down. So particle accelerators are also going to make it into a sphere. So a sphere is going to be theoretically more stable in air because there's airflow. Because the airflow is going to go around it, which is going to keep it into orbit longer. But it's not going to be able to stabilize. Which means if we shot multiple of them, it would just be molten rain. It'd just be molten rain firing down. But that would look pretty cool though. Just imagine it. Just when you're just fighting some kid and that kid just pulls out like some glasses or like a button called mass destruction with the exact chords. But yeah, that'd be pretty cool. That would be it later. But I'm thinking, could we do? Oh, okay. Yeah. Well, considering that it is going to be, well, let's do the math. So pretty much a sphere, because accelerators, because if you think about the accelerator is a circle, and the things that go into it eject, which is usually a block, and it rotates around the circle 1,000 plus times. It goes around in that circle, which then is making it into a perfect sphere, which is aerodynamic, but it's gonna be weighing a lot more. It's like a tungsten cube, a tungsten circle. Doesn't really matter. But since we have 1,000 of these rings stacked on top of each other, we can just blow them all up with an exit port that has a timer with it, with a compository ring. How we're gonna get up to space, we could just do is a simple Loki. We could just put it on a rocket. We could just make a big levitation pad with rockets thrown into space. But we could then also do is there's like a galaxy. Like, have you seen this galaxy? Here, let me show you real quick. Here, let me just draw it real quick. Okay, so this is the basic rotations, but pretty much it's a circle with outer wings that are all too next to the main rocket. So when it spins, but then it's like a rotator right here that generates power so everything else will stay on, because it's a frictionless plane. So pretty much space is frictionless. So I'm gonna put F as friction. And since friction equals 0, there is 0 resistance in air, in space. So that means that when we are building our rocket, we need something to generate energy, which I was thinking this, because the only thing that could stop this was if someone threw something at it to stop the rotation. It would have to be stop the rotation. But if we have these, like, okay, in Among Us, there's asteroid destroyers. So there's an asteroid destroyer right in the sides. So no asteroids could touch it by just firing at it. But instead of this facing this way, it would have to face the other way around. It's just going to use floating air suspension with the wing turbines right here. And then it'd just be like little air. And then there's going to be like a compass in here that knows the exact compass Well, compasses are useless, so we're just gonna use a computer chip, computer, flight pattern. So pretty much, it's just gonna be rotating around the world. It needs to go around the world. It needs to go around the world like 3 times. 3 times. It needs to go around 3 times. Memorizes old camera, and there's gonna be like high-tech cameras, high-focus cameras on all sides. It's there, and then able to see continents, oceans, bays, cities, all that. So if it could all be seen, then there's just gonna be this particle accelerator on board. There's about 5 rings. And they're all gonna get loaded up with the space asteroids. They're all gonna get sucked in through potential movements with the frictionless air because of the divots in the astral plane. They should just be able to get sucked in to the bottom through magnetic poles. Because if there's 2 magnetic poles in it, it just goes right through and it goes to the bottom, which then should be able to then get thrown into through 1, 2, 3, 4, 5, 6, about 5 rings, which all starts it, and then guess what? And then it's all gonna get shot down through the middle. So pretty much it's gonna come through the middle of the rocket, coming downwards as rain. Because there's a potential movement about 3,000 g-forces, so about 3,000 g-forces coming down from a frictionless plane, which is 0. So about 3,000 once this frictionless plane of 0, which then it also is going to be increasing to about 100 to about 2,000. But then we're also considering about g-forces, gravitational pull, which is then going to subtract it to 0. And then with the subtraction of 0, so that means this would be about 100 gravitational pull. Then when it gets done, it's going to be then lessening it by half. So gravitation will be about 1,000, but for us to stay on Earth, we're about 3 million. I'm pretty sure. But yeah, like there's going to be like 5 bolts of lightning coming down. And not to mention, there's probably going to be a second one that's going to be able to launch again in like 5 minutes. So if your enemy stays there for 5 minutes, there's going to be another amount. Because then when it enters back into the stages, it's going to start heating up. So the H is going to be heat, and the heating will be starting from negative, like 100 here to 0 to then 2,000 degrees. Because when space shuttle's re-entry, it's able to melt tungsten, so I'm pretty sure it's about 2,000 degrees. 2,000 degrees coming back into plane, which then should reignite all the magma coming in ports, which then since it's such a high amount of gravity, it's just gonna get thrown straight down. So with they're able to know air drag. So air drag A is gonna be for air, and the air drag should be 0. No, because there's going to be downward momentum. The downward momentum is going to halter it, and it might, because air might just go straight through it. But air is easy. It goes around things. So it might just go around it, causing it to stabilize. It's going to stabilize. ST is going to be stabilized. So it's going to stabilize them. So it's going to be a more direct hit coming back down into Earth's atmosphere, into Earth. So technically, it should hit on point, and there should be less than 100 feet of error. Which, it doesn't sound much, but within 5 shots, that's about 25% chance of hit. But if you're going against a full-scale army, so if you have a bunch of army down on the ground, that's going to be consecutive hits. And not to mention, if it's going to be 5 minutes, it's a 5-minute cooldown. But upon re-entry, and that, there's going to be another second light pair coming down on it. And another one, and another one. So it's about, like, an individual about airspace. So, truly, there's going to be about, like, 4 of them. So it's going to be, like, about 20. So it's going to be, like, the increased chance of that would be about Well, 5 times 5 is 25. So it'd be about 25 shots, and then yeah, it should just evaporate the enemies. They're coming into orbit, going about the maximum speed of a particle accelerator can then go to, which is going to excite all of the matters. Yeah, it should hit the enemy troops within like 3 minutes of calling in. Which I'm thinking I'm gonna call this event called the cluster bomb, or the cluster. Or we could just do World Ender or World Breaker. Because if there's probably a 50% chance that there's gonna be air. There's a 50% chance of air screwing with it. I'm just doing quick calculations, but there is a possible chance that it's gonna go at you. So there is a chance that it could possibly bomb your own troops. Which you could just stop it by just putting a simple shield up that is made out of diamonds, or diamond. Which I believe is anti-resistant to lava, so. But this is all possibilities, because to get these particle accelerators, you're going to need the size of Earth just to hold in 5 of them. Which, not to mention, they're all going to shoot out to the middle, so. Yeah, it should technically work, because if it all gets launched through, we're looking at the Earth, and we're looking at coordinates. So if your coordinates are 7 negative 300, and, which is actually your Y coordinates, X and Z. There's no way you're negative 300. Yeah. So you're usually about 0 above. You're 0 or above, and there's about 100 x 0 or through 100. 100, yeah, 100 should be 100 bases. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you should be right here. Right here. Right here, and you have a Z, which is, I'm gonna go. See, so if your army is between these 2 points, there is a 50% chance of magma splits throughout. Unless it's an ocean. If it's an ocean, you're fighting an ocean battle, you're practically just going to be throwing obsidian into an ocean. Well, that's fun. And it's only spiritual. It's only thinking, because honestly, if you're just shooting asteroids, it's going to get sucked into your air vent, because there's just rotations, mass, which mass isn't going to be sucking. It has a little bit of suction because it's rotations. So yeah, so rotations, and since you're breaking down them into smaller parts, they're all going to get filled up. So yeah, these about like, let's calculate mass. I'm guessing, my guess is probably going to be around like 1,000 kgs. 1,000 kgs. 1,000 kilograms. 1,000 kilograms is about how much these are going to weigh. Or, I don't even know. I don't know what the thing is, but my guess is probably going to be about like 1,000 pounds of force coming back down into Earth, atmospheric pressure, and then, not to mention, it's probably going to be about 2 million joules. 2 million joules. I'm calculating, don't actually check. I low-key don't know how to check that. But yeah, it should technically be about 2 million joules of electricity going down into a tank. Because if we're looking about tanks, so if we're thinking about tanks, energy is barrages hitting it. The gas is usually supposed to be right about here. So like right here, that's the gas. So it's going to heat up the gas particles. Not to mention, it's going to crush. It's going to crush everybody inside. It's going to crush all the tanks' infrastructure. So yeah. And not to mention, there's going to be slag spikes, which is going to be really hot. From coming in from space, it's going to be hot from getting particle accelerated. So yeah, it's probably going to melt through the tank. Tracks, tanks, human beings, human planes, bombers, B-1 bombers, Because if you can airstrike a plane, which is fantastic to do, I low-key want to know what happens when you do that. Low-key, that would be funny. Or you could do boats. Boats would be cool. Boats would be cool. Because you could just hit a bunch of boats and they would sink instantly. Because they're like, it's heavy enough to pressure down the boat. Because if it pressures down the boat enough, it just sinks the boat. And since there's 5 barrage strikes, yeah, you're melting the boat. You are melting that boat. And everybody that, because if it's an aircraft carriers have holes that are meant to not be able to get water in, but when there's big bolts of lightning coming through, yeah, it's going to sink. So there's going to be a bunch of water coming in. And since it's not going to be able to get off, it's going to probably sink the boat. Not to mention it's going to melt, compress. So yeah, that's pretty cool. Yeah, I hope no one steals my design because that would be kind of gay.